Welcome back. We're live at the 2010 Engineering Expo. We've moved our live webcast outside of the patio of the Student Union building. You'll see the activity behind me as our engineering students display their larger projects here outside. We have Team Jet Tread that's been working on a scooter project. Jacob here from their team is going to introduce the project for us and tell us a little bit about what they've done this year.
All right, thanks for the introduction. Basically, our goal was to put regenerative braking on this scooter. The idea is that we wanted to have a last-mile transportation kind of scooter. We wanted it to be lightweight, something that you can ride like the bus, fold up, carry with you, and still have capabilities of powering and regenerating. So we should never actually have to plug this into the wall, and you should always have power to it.
Did your team come up with this idea, or who's your client? Where did this project start?
Yeah, our client is Greg Donahoe. He actually rides a scooter. He is an avid scooter rider. And he loves riding a scooter to class every day, but he noted that it just kind of sucks riding the scooter uphill. So he was looking into buying an electric scooter, and the problem with those is they're too heavy, they're bulky, you can't really carry them onto the bus with you. And he thought a good solution to this would be to have just a power assist scooter and to put regenerative braking on it. So Greg Donahoe had the idea and presented it to us as engineers.
Can you walk us through your design process a little bit, where you started at with his idea, how
Sure.
you took it along, and where you're at now at the completion of this project?
You bet. So our project was really open-ended. We basically started with that simple idea. We wanted a scooter regenerative braking, and we wanted it to be light. So we actually had a process that was a little different than most engineers here, or most projects. Ours was a bit iterative. We started off with a simple rolling prototype. This is our final prototype, but we started off with something much smaller, just a scooter with a basic motor on it, so we could try to figure out how much energy was required to go into it and what kind of energy we could get back out of it. And then from there, we reevaluated our goals and made new specifications, and then we came up with this design. And from here, we actually put regeneration on the scooter. We have capacitors, and this has complete functionality. It can take the power and put it into the motor and power the back wheel, and it can also take power out of braking, put it back into the capacitors, and use that energy later.
Very cool. Quite a few different components here. How did you work on those different components? Did you split up into smaller groups? How big of a team, and what different disciplines was your team?
Yeah, we definitely split up into small groups. We basically looked at the function of each component. We thought we needed some sort of energy storage, some sort of motor, a controller to work with the motor, and we needed a user interface. So we broke everything up into small components and divided it accordingly. We have 3 mechanical engineers on this project and 2 electrical engineers. So we gave some of like the controls and capacitor work to the electrical engineers, while we focused more of like the motor and power requirements for the mechanical engineers.
How has the project been, taking a real world project and applying the theory and the skills that you've learned in your classes so far?